Bismillahirrahmanirrahim, dear students. Welcome to lecture. Now, in this lecture, we will discuss the time complexity of 2D maxima problem, and it is in fact solution of assignment. In assignment number 2, I gave you a task that find the time complexity of the two algorithms given in the next slides, and both the algorithms solve the same problem. Means there is no difference in input and output. And if in some algorithm it says sorting and you don't know how much time it takes to sort, so just for your convenience consider it that sorting takes n log n time. And after you have done with that, after you have calculated the time complexity of both the algorithms, just compare them, so we can see how much faster or how much slower one algorithm is as compared to other. So what was in fact the problem? And I told you that whenever you are solving a problem, the first step is to understand the problem. Whenever you have understood the problem, it means half of the problem has been solved. If you don't get what is the core essence of the problem, what in fact the real problem is, what is the problem statement, what is the understanding of the problem, what actually is required, if you don't know this, then no matter how much effort you give, it is all in vain. So just focus on it. Suppose you want to buy a car and you want to pick the fastest car, but you know fast cars are very expensive, and you want to buy a cheaper one. You cannot decide which is more important, speed or price. Definitely you need a type of car that has more speed in a very less price. But if you have bought a car and you know there was another car that is both faster and cheaper than the car you have bought, then definitely that is not the situation that you will like. So we say that fast and cheap cars dominate the slow and expensive cars. So we are given a collection of cars, and every car has two attributes. One is speed and second is price. So we want to list just those cars that are not dominated by any other car. So what can be the problem here? That you can plot, just for your convenience and sake of understanding, one of these two properties on x-axis and the other one on y-axis. Suppose you have plotted your price on x-axis, so it means the car 5-1 means the value of x is 5, it is expensive, and this value this car with value 13, value of x as 13, is cheaper. And as far as y-axis is concerned, so suppose that we have declared is an axis for speed. So the car 2-5, here y value is 5, it is slower as compared to for 11, because here speed is 11. So I think now you got what these points in fact indicate. Now there are two types of points here. One are white points and the other are gray points. You see, white points are those points that are dominated by other points. For example, 4 and 4. So there is at least one car, let's say 7-7, which dominates this car. Means speed of this car 7-7 is more than speed of car 4-4, and similarly price of this car 7-7 is better than price of car 4-4. It means that with respect to both the properties, this car is dominating this car. So definitely you will not like to buy a car that 4-4 that has been dominated by another car. So if you have a collection of 1000 cars, so how will you know which of the cars are not dominated by any other car? So these four, in these 12 points, these four cars 7, 13, 12, 12, 14, 10 and 57 are the ones which are not being dominated by any other. By domination we means they are great, they are better in both x and y value. So these four cars will be declared as 2D maximum, means the point by maximum points, the maximal points we need, we mean the points that are not dominated by any other value. All other remaining 8 points have been dominated by some other point. Now, how to if these points 12 or 18 or whatever it is, if there are n points as an input and you run and these n points are given as input to an algorithm to find these the maximal points. So there are two types of approaches. One is brute force, and that is our algorithm number 1. In brute force, what we do is we compare each value with every other value and find the maximum values. But in plain sweep algorithm, we do not do this, because in brute force, as we are trying every possible combination, so it means that it will take a lot of time. It will cost you more with respect to time complexity. Plain sweep algorithm is giving you the same input but with a better time complexity. So that is why this assignment has been given to you, to find how much optimal, first which of the algorithm is optimal. Now you are getting the point that the first one is not optimal. It will take more time, because I have told you that here we are going to try every possible combination and it takes a lot of time. So what we are going to do, we are going to simulate both these algorithms, and you will understand how these algorithms work, and then we will calculate their time complexity. So first look at the brute force algorithm. Now suppose we have these 12 points, P1 to P12, where n means total number. So total number are n is 12, means 12 points, and these are their x and y coordinate values. As far as space complexity is concerned, we just need one variable maximal and one for I, one for j. So we just need 3 extra memory locations. So it is a constant space. S of n is equal to order of 1. So it's not a problem. The main problem is how much time it takes. So first we will simulate it on this algorithm. You see, first statement for I is equal to 1 to n. So I will be pointing towards the first point, means this point in fact denotes a car with some x and y values. So it will be pointing towards the first car, or in other words first point, and we will suppose maximal is true, that this is the maximum value, 713 is the maximal value. Now for j is equal to 1 to n, now we are going to compare this first car with every other car. How? Here it is. If I is not equal to, of course we will not compare a car with itself. It's self comparison. So this I is not equal to j is avoiding it. And these two are in fact the other conditions which are going to check whether there is any other value whose I and j value, whose x and y value dominate the x and y value of the current point. And we are comparing this first point with every other point. So I is equal to 1 and j will go from 1 to this 12, and it will compare this point 1 with every other point except the first point, because I is not equal to j condition is false, it will do nothing. So j will be incremented. Now it will compare it. I is not equal to j. 12, 7 is less than equal to 12. Yes, 12 is maximum, but 13 is not equal to is not less than equal to 12. So last condition becomes false. So it means 12 is not maximal of 713, means it does not dominate 713. So we will try the next one and we will see here again condition becomes false right in the beginning, because 7 is not less than equal to 4. So here 7 is less than equal to 9, but 13 is not less than equal to 10. So last condition becomes false. So when we iterate all it right through the end, we will see that no other point has dominated 7, 13, and the value of maximal remains true. So as this value remains true, we are going to output it as a maximal value. So this was the first maximal value that we have got. Similarly, let's try another iteration of outer loop. So here we will compare with 7, 13, 12, 12 is now being compared with 7, 13, condition becomes false. Here I is equal to j, condition becomes false. Here 4 is less than 12, so how can it be maximal? 9 is less than 12, 2 is less than 12, 4 is less than 12, 5 is less than 12. The middle condition is false. 15 is greater than 12, so the middle condition is true, but 7 is not less than equal to 12, so the last condition will become false, and we will move forward. First condition true, second false, means the middle condition true and the third one false, and here again it is same case. Here second and third condition are false. Here again last two conditions are false. So it means we again got another maximal value, so we're going to output it. And similarly, if you iterate it, it's a very simple algorithm. So brute force algorithms are easy to understand. They've got no such complex coding or complex logic. So you can iterate it, and after iteration you can see we will get just 4 maximal points. So you may complete this simulation yourself, because brute force algorithms were very easy, straightforward, naive. So let's analyze it. You see, what is the total time complexity for these 8 steps? First, there is an outer loop. An outer loop runs n time. So n times it is going to execute its body. So what is its body? Its body contains a loop, this loop. So it means you have to calculate the time complexity of inner loop, but it is not just the loop. So see, there is an assignment, there is a comparison, there is an array access. So these are 3 operations. So let's suppose these are constant operations. So total time complexity will become T of n is equal to n into c plus time complexity of inner loop. So what is time complexity of inner loop? It is n into c. How? You see, inner loop runs n times. So n times it is going to do some work. So n into some work, and what that work is, you see 3 comparisons and 1 assignment. So 4 operations. So these are constant time operations. So these constant time operations will be done n times. So it will become n into c. So if you solve this, it will become nc plus n square c, and higher order term is n square. So we can write it as order of n square, and in other words we can say that time of this function grows quadratically, n square. And this is n square, we already discussed it, that it is not an optimal algorithm, so we have to find a better one. So here is the better one, plain sweep algorithm. How will it work? Just have a look. We have got 8 steps. Initially we have got the same input points as we had in the previous algorithm. So first step is sort p in increasing order by x. We have sorted it. How sorting has been done, it is not to be discussed here. We have discussed it in other lectures, and we are going to do it in more lectures as well. Next, there is stack. Now I is equal to 1 to n. Now x wise every next element is dominant, so we will just compare y. So here you see there is just y, there is nothing like x here. So while s is not empty, so condition becomes false because stack is empty. S dot top is less than y, it will not be executed because this condition will not be checked, because s dot not empty is false, because s is empty, so it will not do this pop operation. It will skip this loop and it will move towards this push statement. This push statement is not included in while loop, it is in body of for loop, so don't get confused. So it will push this value on the top of stack, and that is 2 5. Now for the next iteration, I will be incremented, and now stack is stack is not empty, so condition is true, and s dot top dot y means value at top of the stack, we are going to compare its y value, means 5, with y value of the current point. So 5 is less than equal to 11, condition is not true, so it means we are going to skip this loop, and we will no, p of y is less than, yes, 5 is less than 11, so we are not going to skip, we are going to do this pop operation. Now stack is empty, condition is false, so it will move forward towards this push operation. So we are going to push this 411 here. Next, for I is equal to 1 to n, so I will point towards the third point. Previously it was pointing towards 411, now towards 4 4. S is not empty, 11 is not less than 4, so it will not do pop operation, it will move forward to push operation, and I will be incremented. S is not empty, 4 is not less than equal to 1, condition is not false, sorry, condition is not true, so it will not do pop operation, it will push 5 1 on top of the stack. Now stack contains 3 items. Up to now these 3 items are the maximal, but let's see what happens further. So I will be incremented, and as stack is not empty, 1 is less than 13, because we are going to compare the y value of the top of stack with the y value of the current point. So 1 is less than 13, 1 is less than equal to 13, so it will pop it. Again 4 is less than 13, it will pop it. Again 11 is less than 13, it will be popped. So stack is now empty, while loop will be skipped, and we will push this value 713 here. So now just there is only one value, one maximal value up to from point 1 to point number 5. In the next iteration I will be incremented, it means it will now point towards point number 6, point to point number 6. Now while stack is not empty, stack so condition is true, 13 is less than 7, no, it will push. Again I will be incremented, stack is not empty, 7 is less than 10, so it will be popped. 13 is less than 10, no, it will not be popped, so it will be pushed. And again I will be incremented, we will check 10 is less than 5, no, so if it is a no, then it while loop will be skipped, and we will do the push operation. I will be incremented, 5 is less than 12, yes it is, we will pop it. 10 is less than 12, yes, we will pop it. 13 is less than 12, no, so body of while loop will not be executed further, and we will have a push operation. Again I will be incremented, 3 is less than 12, sorry, 12 is less than equal to 3, no, so no popping will be done, it will be just a push operation after while loop has been ended. And I will be incremented, so 3 is less than 10, yes, it will be popped out, and then as 12 is not less than equal to 10, so while loop will end and we will push this. Now what will happen after this pushing? I will be incremented, and 10 is less than equal to 7, no, condition is not true, so popping will not be done, it will be just last push operation, and we have done with, because I is now exceeding the limit, so for loop will end. And what will be the what will be executed now? The last statement, output the contents of stack. By output we mean we are going to pop all the elements. So we are going to pop all the elements, and we are going to print it. So these are 15 7 14 10 12 12 7 13, last in first out procedure, you know. So it is the output, and it is the same output, maybe the order is changed. Those 4 values that were outputted by the first algorithm are in some different order, so order is not matter here. What matters here is the output, and we have got our output. Now what is the analysis? See, here we have 3 portions. First, there is sorting is done. So total time complexity will be equal to time required to sort it, and then time required for these two nested loops, and at the end time required to output. Some things are very simple because sorting takes order of n log n time, because this was already given. And output the content of stack means to pop and print. And if there are n values, so stack can contain, if there are n values and input, so stack can contain maximum n values. So if it contains maximum at n values at the end, so it means we cannot pop more than the values that have been pushed. So if we have pushed n values, we cannot pop more than n values. So maximum pop operations that last statement can do are n, and every pop operation takes some constant time c, so it takes in fact n dot c. So order of n log n and n dot c, these are very simple. Now we will now see what is the behavior of these nested loops. So in the first go, maybe you can say that outer loop run n time, and there is a while loop, so it maybe it has some n pushing popping operations, so n into n is n square. No, if you write here n square, it means it takes more time, or in other words you can say that it also runs in order of n square time. So how can it be better algorithm than the first one? So it is not just a matter that whenever you see two nested loops, you say just multiply this. No, you will see how much work has really been done. See here, the outer loop contains this while loop and this push operation. So pushing has been done by outer loop, and this popping has been done by the inner loop. Popping is done only when there is some value was already pushed. So outer loop, so if there are n values, so outer loop cannot push more than n elements on the stack, and hence inner loop cannot pop more than the elements pushed on it. So there are a maximum of n pushes and n pop operation performed collaboratively by both of these nested loops. So there are in fact total 2 n operations, n operations for push and n operation for pop at maximum. This is the worst, I mean it is the upper limit. It cannot exceed it. So there are in fact n push and n pop operations. You can, in other words, you can say 2 n operations, and every push and pop operation in stack we have already discussed, it takes a constant time, so it means it takes 2 n into c time. So it is nothing other than order of n. So because 2 and c are constant factors, so we can eliminate this. So time complexity of nested loops is in fact not order of n square, it is order of n. So substituting this value here, we get T of n is equal to n order of n log n plus order of n plus order of n, or n dot c. So which is the higher order term, n log n. So we can write it as T of n is equal to n log n. So time complexity of previous function is n square, and time complexity of this algorithm is n log n. If we take a ratio n square divided by n log n, the ratio is n divided by log n, and by this ratio, we just want to know how much slower or how much faster one algorithm is as compared to other. So the ratio is n and log n. So n ratio log n. So it tells us that if there is an input size of 100 values, first algorithm, the brute force version, is 15 times, approximately 15 times slower than the plain sweep algorithm, or in other words, plain sweep algorithm is 15 times faster than the first algorithm, the brute force version. And whenever and as n is increasing, this ratio is changing rapidly. So for n is equal to, for such a large number of values, if plain sweep takes 1 second, brute force will take about 14 hours, and it will take much difference when this n is very large. So just put values and check out how much faster and slower one algorithm is as compared to other. So this was the main problem that we have discussed today. If there is any queries, I am always available to you 24/7 through email, through phone, or via WhatsApp group, or whatever means it is convenient to you. But I am waiting for your queries, and I am not getting your queries on time.